Hi everyone! In this video we're going to go over the Malonic ester synthesis. So this is a really interesting synthesis because we're going to turn a halogen from an alkyl halide into a carboxylic acid. So notice we're replacing this halide, the X, with all of these atoms here that I'm circling in blue. And also notice that we've added 2 carbons to our alkyl group R. So that's a pretty cool transformation. So again, the Malonic ester synthesis transforms a halide into a carboxylic acid with 2 new carbon atoms. Now, you're probably thinking, how in the world are we adding all these atoms in place of a halogen? Well, it does involve the use of something called diethyl malonate. So I'll just draw that down below here. So this has 2 esters separated by a carbon, and we call this diethyl malonate. So let's look at the mechanism for this reaction. So we're going to start with that diethyl malonate. And remember that if you have 2 carbonyl groups with an alpha carbon in the middle there, the alpha protons are very acidic because the conjugate base is very stable. So in this first step, we are going to use an alkoxide base that matches the ester leaving groups, similar to what we talked about with previous mechanisms. So that alkoxide base is going to grab a proton and electrons will be left behind on the alpha carbon. So again, this conjugate base that we're forming, the enolate, this is very stable. So now this is where our alkyl halide comes into play. The negatively charged carbon is now going to attack the alkyl group, which will then leave electrons behind on the halogen. Now remember, for these types of reactions where we're using substitution and an alkyl halide, we want the alkyl group to be pretty simple. So the alkyl group should probably be primary or methyl. Secondary sometimes works, but for the most part, this should be a pretty simple alkyl halide. All right, so now we're just adding that R group to the alpha carbon. Okay, and in the next step, we're going to add some acid. And remember, when you have an ester and you add acid, that turns the ester groups into carboxylic acids. So the acid here is going to convert both esters into carboxylic acids. Okay, now in this next step, I actually want to show you a slightly rotated version of this intermediate. So I'm going to erase this second carboxylic acid that I drew, and I'm just going to rotate it so that the alcohol is pointing up and the carbonyl group's pointing down. So I just kind of rotated that bond there. Now the reason I did this is because in the next step, the pi electrons from the carbonyl group on the left, those are going to create a new bond with hydrogen. So that oxygen on the carbonyl group on the left is going to become an alcohol. That means that the electrons between hydrogen and the other oxygen are going to move down to form a double bond. And that's going to form a Texas carbon, right? So we have to do something to alleviate that stress. And in this situation, the bond down below between the carbonyl carbon and the alpha carbon is going to break. So what's actually happening here, because this is a little confusing, we're losing one carbon and two hydrogens. So that's our leaving group. Oh, whoops. There we go, leaving group. All right, so what we end up forming looks kind of funny. We have two alcohols with a double bond, and then our alkyl group that we added earlier. And then we're also forming CO2 gas, carbon dioxide. Now, the molecule with the two alcohols on it, that is going to tautomerize, because we do kind of have an enol in there, right? We have an alcohol and an alkene. So that's going to tautomerize into our carboxylic acid. And that is our final product. So this is a very long mechanism again. But again, the main idea here is that we're replacing the halide on our alkyl halide with this carboxylic acid here, plus that CH2 group on the right there. Okay, now you can also perform a dye substitution. You don't just have to substitute this once. So let's talk about how to add two alkyl groups to our malonic or our diethyl malonate, and then what that would result in once we add some acid. So we're going to again start with our diethyl malonate. And we're going to first add that alkoxide base to deprotonate. Then we're going to add the alkyl halide so that we add a particular R group to our diethyl malonate. Then we're going to do this all again. So unfortunately, we can't add the alkyl groups at the same time. We have to do it step by step. So in the third step, we'll add more of our alkoxide base, and in the last step, we'll add more alkyl halide. So then that will give us a dye substituted malonate here. And then we add acid and heat to form our carboxylic acid. But this time we have two R groups. Now you might be wondering, didn't we already talk about a reaction where we could turn an alkyl halide into a carboxylic acid? And you would be correct. So remember, back in our carboxylic acid chapter, we said that if you react an alkyl halide with magnesium to turn it into a Grignard reagent, then you could add CO2, carbon dioxide, and finally acid to turn your halogen into a carboxylic acid. Okay, so what's the difference? Well, in our malonic ester synthesis, we're using that alkoxide base followed by an alkyl halide followed by acid and heat. And this is going to give us something pretty similar, except we're adding not only that carboxylic acid group, but also an extra CH2 group on top of that. So this alpha carbon here. So up above, we're just adding a carbon, 2 oxygens, and hydrogen. But down below, you can see that with malonic ester synthesis, we're adding 2 carbons, 2 oxygens, and a hydrogen. So the malonic ester synthesis could be really useful if, for instance, you need to add an extra carbon to your chain of carbons, and then maybe you turn your carboxylic acid into something else. But, you know, this could fit nicely into a synthesis reaction. All right, so I think we'll stop there. In the next video, we're going to talk about a different type of synthesis called acetoacetic ester synthesis. So it's kind of similar to this malonic ester synthesis, but instead of a carboxylic acid, we end up with something a little different. So we'll talk about that next time.